Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Teresia Afilanini Teluma. Saya dari kelas SI 22A. Di sini saya akan mempresentasikan karya ilmiah saya yang berjudul Mesh Network Performance Analysis in a Wireless Sensor Network. Mesh network within WSN. A definition of WSN. Wireless sensor networks, or WSN, is a system consisting of small sensor connect wirelessly to detect, measure, and convey information about the surrounding environment. These sensors usually have the ability to detect temperature, humidity, pressure, motion, and other environmental parameters. The data collected by the sensors is then sent via a wireless network to be analyzed or to take the definition of mesh network. Mesh networks in wireless sensor networks or wireless sensor networks or WSN are a network topology in which sensors are directly connected to each other to form a fully connected network. In a mesh network, each sensor and function as another then can receive and send data to other sensors. With a direct connection between sensors, a mesh network is able to create a network that is resilient and can tolerate failures of communication nodes or channels. See advantages and challenges of mesh networks in WSN. Advantages of mesh network in WSN. A. Redundancy. Mesh networks have broader redundancy, which means data can be transmitted via alternative routes if the main route is lost. This increases the reliability and resilience of the network against node or communication channel failures. B. Scalability. Mesh networks are easy to expand as each sensor can be an additional connection point. The network can grow as needed without compromising overall performance. The network protocol for mesh networks. There are several network protocols that are commonly used in mesh networks in WSN, including 1. Routing protocols. Routing protocols are used to determine the optimal route to transmit data between sensors in a mesh network. Some of the common routing protocols used in WSN are AODV, or ad hoc on-demand distance vector. This protocol uses on-demand techniques to find routes between data sources and destinations. Routes are only formed when there is a request for data transmission. B. DSR, or Dynamic Source Routing. This protocol allows sensors to dynamically determine routes through the routing change stored on each sensor. Data is sent through a series of nodes between the source and COLSR, or Optimized Link State Routing. This protocol focuses on optimizing the use of network resources, including bandwidth and energy. OLSR uses link state routing techniques to build and maintain network topology information analysis in WSN. A. Performance factors analysis. In this study, we will analyze 3 main performance factors in a mesh network in wireless sensor networks, or WSN, namely latency. Latency refers to the time it takes to transmit data from a source to a destination over a network. We will measure latency in a mesh network to understand the response time request to transfer data. Throughput. Throughput refers to the amount of data that can be sent or receive it in 1 unit of time. We will analyze the throughput of the mesh network to determine the capacity of the network to transmit data efficiently. Energy consumption. Consumption is an important factor in WSN because sensors often operate with limited resources such as batteries. We will analyze energy consumption in a mesh network to understand the level of energy consumption by sensors and identify strategies that can optimize energy. B. Method of collecting data. Performance data will be collected through simulation using appropriate wireless sensor network software. We will experiment with a variety of different mesh network scenarios, including the number of sensors, the size of the coverage area, and the degree of mobility. Each scenario will be run in several iterations to get consistent data. The performance data collected will include the latency, throughput, and energy consumption of each sensor in the mesh network. This data will be recorded and stored for C. Simulation and data processing. The simulation will be carried out by entering predetermined network parameters such as the number of sensors, movement speed, signal propagation model, and the communication protocol used. Through simulation, we will collect the performance data needed for analysis. After data collection is complete, the data will be processed and analyzed using appropriate statistical methods and analytical tools. We will use graphical techniques to visualize the result of the performance analysis in a clear and informative. The performance analysis results. The results of the performance analysis will include a deep understanding of the latency, throughput, and energy consumption in a mesh network within a WSN. We will report the results quantitatively and present them in graphs or tables for easy interpretation. The results of the performance analysis will provide insight into the performance of the mesh network under different conditions and help identify the factors that affect. Conclusion. In this paper, we have analyzed the performance of mesh networks in wireless sensor networks. Mesh networks offer reliable and efficient data transmission by establishing alternative and redundant routes between nodes in the network. Performance metrics such as throughput, latency, and packet delivery ratio are used to measure mesh network performance. Factors such as the number of nodes, the distance between nodes, and the protocol used also affect network performance. Analysis of mesh network performance in wireless sensor networks can assist in the development and optimization of wireless sensor networks in the future.